what we did last semester, because we are supposed to have advanced from where we ended off last semester. But I'm going to look at some other aspects before we go back to the aspects of integration and differentiation, okay, which we were looking at last semester. Okay, so you are welcome to Building Mathematics 2 class. What are we looking in this course? What are we looking at in this course? Yeah, so a summary of the course outline, okay? The detailed outline I will pass on to you in due time. But basically, we are looking at 4 major areas, okay? We are looking at Laplace transforms, we are looking at differential equations, we are looking at matrices for solving systems of equations, and then we're also looking at statistical concepts, which we need very much for our research work, okay? Yeah, so as a result of that, and also considering the fact that some of us were still struggling with differentiation and aspects of calculus, I've decided to start with statistical concepts, okay, for this very class. Okay, so we'll begin with statistical concepts, okay, then we move on to systems of linear equations using matrices, okay, then eventually we'll come back to differential equations, okay, and what I want to advise, my advice for you, I always keep advising, but this time, okay, I think we were all picking up last semester, and by now you've all realized where the weaknesses are. And I'm sure a lot of you might have addressed some of those weaknesses. So our advice, especially when it comes to the Zoom online lectures that we all attend, is very important to attend the Zoom online lectures so that you can ask questions and understand the concepts. Okay, and then once I also pass on the videos, you make every effort to have access to the videos and watch them. Yeah, that is the best way we can approach the course and get a very good grade for the course. So that is my advice as we are about to begin this semester's courses. So basically, we are looking at these 4 areas, and today we are starting with statistical concepts. Okay, and the statistical concept, we'll be looking at a number of topics, okay, where we begin with data. In fact, even the whole concept of statistics, we look at data, how to classify data, or data presentation. We look at data description, where we look at measures of central tendency, okay, measures of dispersion. We also look at how to describe the distribution of data. Okay, then we'll proceed into looking at that you are writing on the screen. Okay, so from there we'll be looking at probability, the concept of probability theory. We'll introduce ourselves to probability. Okay, then we look at the rules, additive rule, multiplication rule, conditional probabilities, properties of the probabilities. Then we'll move on to probability distributions and their properties like the expectation and then the variance of a probability distribution. Once we are done for both discrete and continuous, we'll look at some special distribution functions like the Poisson distribution, exponential distribution, and then we'll move on to statistical inference, where we'll be looking at the aspect of hypothesis testing on one mean or two means, and interval estimation, okay? That will be the sub-themes under the first topic which we are looking at, which is what? Statistical concepts, okay? Cool. So we want to begin from here, and we'll, for the next let's say 5 weeks, we are going to dwell on statistical concept. Okay, so try as much as possible to follow everything we are doing in class. And I also gave an instruction to the course rep. Okay, everybody should have a calculator, a book, and a pen by you. Okay, for this very topic, it's very necessary you have a calculator, a book, and a pen by you. Okay, as we are about to begin. Okay, so lecture 1, statistical concepts. We have our learning objectives. Okay, so we're looking at a concept of statistics, data presentation, explain the purposes of the measures of location variability and distribution, okay, like skewness, kurtosis, etc. We'll move on to the concept of probabilities all the way to hypothesis testing. Good. Now, what is statistics? Statistic one is a branch of mathematics, but in another context too, we say that statistics is a science, okay? And it entails the collection of data, organizing the collected data, presenting the data in an informative way, and then going further to analyze the data, and finally interpreting the results of the analysis, okay, to assist in what? Decision and effective decision making. Okay, so we say that it's a science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making effective effective decisions. What do we mean by collecting data? Data collection can be done in several ways, okay? So we can collect data by means of questionnaires through surveys, okay? We can collect data by means of censuses, okay? We can collect data, by means of ad hoc surveys, so many forms, okay? Even medical data is also a form of what? Taking data. Okay, so data comes to us in so many forms, okay? So when we collect the data systematically, it falls under statistics. Then again, after we've collected the data, we need to organize this data, okay? And sometimes there are mistakes in the data, and we also need to put them, okay, well organized in, frequency distribution tables, okay, and make all those corrections. We call them data organization. Okay, then we also talk about data presentation, where we want to make some meaning out of the data we have. Okay, that is what we see from time to time on our TV sets. Okay, from every now and then on stock exchanges, you have some curves. Okay, trying to depict what the exchange rates and all that. Okay, so this type of graphs helps to give us an overview of what is happening in the data or in the distribution of your data sets. Okay, sometimes you have items like pie charts or like histograms, okay, which helps you also to describe the data set. So these come under data presentations, okay? And when we present data, we try to make meaning out the raw data that we have what? Selected. Now, a lot of times the information we get, okay, out there ends at a presentation level. But for scientists or for researchers, we usually want to go further. We conduct what we call as analysis. Okay, analysis means you are comparing the information, the sample information you have with theoretical distributions. Okay, and then once that is done, we go on to infer, okay, the results we've collected on the entire population, okay, to assist us to make decisions for the entire population. Okay, so basically, we can see that there are two forms or two main branches of EV statistics. The first branch is what? The descriptive statistics, where we are dealing with collecting the data, organizing it, and presenting the data in an informative way. So which means in descriptive, we will end up having some pie charts, okay, where we have the proportion of males as to females. So maybe a pie chart on a dropout rate or the number of students that have dropped out at the basic school level, okay, based on gender. So the pie chart will give you, okay, the sector distribution of males and females dropout at the basic high level. That alone communicates an information to us, okay, and we are able to make some action or know what is happening in the population, or even be able to compare, okay, the distribution in one population as against another. Okay, good. Then we have the second one, which is the inferential statistics. There we are going to compare, here we compare the proportion, okay, of males that have dropped out with a theoretical distribution. Okay, whenever we do this, we say we are conducting analysis. Okay, we are conducting analysis, and then once we finish with our analysis, we come out to infer the result from our analysis, okay, on the population, so as to make effective decisions, which would be beneficial to the entire population. So let me take a break and ask for one or two questions, then we continue. So if you have a question, you can raise up your hand quickly. If you have a question, just raise your hand, I'll mute you, and then you ask your question. Any question? Yeah. Yes, go ahead. Yes, Joseph.
Yeah, good evening, sir.
Yeah, good evening, Joseph.
Yes, it looked like I came a little bit late. I started from the presentation.
Yeah.
I came a little bit late. I started from the presentation. So if you can let me get the collecting and the organizing, listen that I didn't get those ones clear.
Data collection, we collect data in so many forms. Okay, when people visit hospitals, data is collected, okay, by way of measuring your temperature, medical conditions and all that. That is also data collection. So the hospitals have databases, okay, based on their patients. We can also collect data using survey instruments like questionnaires. Okay, you can have questionnaires, then people answer it. Then from there, we have your data which you use for your research. Okay, and there are so many ways of going about this data collection. Then when we come to organization, we are saying that after you've taken the data, for example, you use the survey questionnaire to ask for information, okay? And then in your question one, you ask for the age of the individual, okay? You ask for age, and then the person selected an age of 18 years, okay? Age, the person said 18 years. Then you ask for the person's class, class, and then he says maybe class 1, okay? So it becomes a little bit strange. Yes, once a while we have outliers where people start, are now starting school, but that shouldn't be frequent. You understand? So over there we do editing of the data, you do coding of the data, and data entry in data organizations, okay? And then once we are done with organizing the data itself, you want to present the data in an informative way. I think that is when you came in. So we'll end there. Yeah, any other question? So Joe, you can lower your hand. Okay, any other question, please? Okay. It could be question, it could be contribution, okay? So if you also have a contribution, you can add it up. Okay. Yeah, I think Joe, your hand is still up. Okay, so I've unmuted you. Go ahead. Yeah, Joe, I've unmuted you. Your hand was up. Oh, okay. Then let's proceed. Yeah, so we are moving on to the next slide. So we know what I think Engineer Samoa has his hand up. Yeah, Engineer Samoa, please go ahead. Go ahead with your presentation. Okay. I think he's having problems with his network. Let's continue. Okay, we can pick his question later. Okay, so we've talked about the two branches of statistics. Okay, now the next thing we want to look at is the types of data we can have, because basically we are talking about data. Okay, so if that statistics is basically about data, then we need to know the orientation or the nature of data itself. Okay, now to understand data, we need to understand two main terminologies. The first one is what a variable is. Okay, so a variable is any criterion or characteristic which changes from one object to the other. Okay, so an example will be age. Okay, so if I ask engineer, let's say Salifo, what is your age? He might give me 32. Then I ask Amma, what is your age? He will tell me 20. So the value of my age is changing from one person to the other. Okay, so we say that age is a variable. Good. Now another variable will be the choice or your preferred color. If I should ask Eben, what is your best color? He will tell me white. I ask Kojo, he might tell me red. Okay, so color, the value of color is changing from one object to another. So we say that color is what? Preferred color is what? A variable. Very good. Now, the response given to the variable is referred to as a variate. Okay, there. So when Amma tells me my favorite color is red, that response is referred to as what? A variate. Okay, so you take note of that. Now, I have a data set here, and we want to, scrutinize the data sets and try to understand the types of data we can have, okay, and how they come about. Okay, so when we look at this data here, with our understanding, we can see that usually I prefer to ask students how many variables do we have here. So let me use the same approach. How many variables do we have in the data set? Okay, showing. So kindly raise your hand if you want to answer, or let me unmute you. How many how many variables do we have in the data set? Yeah, Engineer Samoa, go ahead. Engineer Samoa, I've muted you. Okay. Adams, I think your network, there's some feedback from your end. That's why I muted you. But Engineer Samoa, I'm asking you to, you have your hand up. You have your hand up. Okay, I think he's having challenge. Can you, what about just sending a chat? Okay, just send me a chat if it's a question so that we know exactly what it is. Yeah, so back to my question. How many variables do we have? Yeah, Kenda, yeah, let me have your.
I see two here.
Two, okay. Which are
the prices of shoe and then the weights.
and the weight. Okay.
Yeah.
Very good. Okay, Kenda, thank you for your response. Any other response? Any other response? Any other response? Or just feel free to answer. I mean, participation is also part, you understand? So for participation, you don't necessarily need to get it right. Okay, I think I've seen somebody's chat. Doc says, okay, Gabby says 3. Okay, somebody says, Asamoah says his mic is not functioning. Dr. Sabali says 12. Samoa says 3. Okay, very good, very good, very good. Okay, very nice to have your responses. Okay, Daniel says 5. So you can just type it for me so that we don't have too much. Adams, just type it for me. Type your answer for me. Okay, so let's see who is right. Okay, now we said that a variable is a criterion, any characteristic which changes from one object to the other. Okay, so if you look at this data set here, you realize that when I asked for gender, this is from a survey instrument. Adam says 6, Theophilus says 6, fantastic. So when I asked for gender, the first person told me his gender was male. Okay, the second person's gender was what? Female. Third person was female. So it means that gender is changing from one object or one person to the other. So this is variable 1. Then price of shoe. So we asked the first person, what's the price of your shoe? He says 300. Next person, price of shoe, 250. Next person, 270. So this is also what? Variable 2. Nationality is also varying from one person to the other. So V3, variable 3. Number of children. Okay, so they have children. So variable what? 4. Then their weights. So we have variable 5. And then their rank. They happen to be what? In the military. So variable what? 6. So we have what? 6 variables here. Very good. Now I get your point. Those who said 2 and who said 3, because usually we are conversant with what? Numerical data. Okay, without knowing that qualities are also what? Data. Qualitative values are also data. Okay, so for us as building engineers, okay, we are only interested in the tensile strength of the concrete. Okay, but you see the data on the type of cement that was used, whether it was GASAM or it was CIMAF or it was diamond, it's also data. You understand? It's also data. So the type of cement used is also what? Data. And then the tensile strength of the material is also what? Data. Just that they differ in their nature. Okay. So clearly, when you look at them, that tells us that then it means we have 2 main types of what? Data sets. We can have data sets which are numerical by nature, and then data sets which are what? non-numeric by what? By nature, okay? So we can have data sets which are numeric in nature, and then some which are non-numeric, okay? So it means that we can classify data, okay, the data we have here. Don't forget, this is the data, okay? This is the data we have, and then these are the variables, okay? So the data we have can be classified into two. We have the numeric types, and then we have the non-numeric. These are non-numeric types, so they are quality. Quality. You understand? Good. So let me clear the screen. I want to bring the flowchart. Then after that, pick questions. So we can clearly see that we can have quantitative numeric type of variables and then qualitative or categorical variables. Okay, good. So we want to look at examples. So in examples, when we go back, we'll notice those who have your videos on would appreciate for the sake of the bundle. So we don't have challenges, just put your video up for us. Okay, let's continue. So we have, this is numeric. So we can see that price of shoe is numeric. So it's a numeric variable, which means that we are going to get numeric or quantitative data. Then number of children is also quantitative. So we get quantitative data. And then weight is also quantitative variable. So we get a corresponding what? Quantitative what? Data. Okay, good. Then the others are all quality in nature. Okay, now we have established the fact that there are two main types of what? Variables, qualitative and quantitative. Now, within this quantitative and qualitative, there are also slight differences. You will notice that price of shoe, okay, is in whole numbers. Number of children is also in whole numbers, okay? And I always make this joke, okay? You can't have number of children and somebody tells you, I have 2.5 children, okay? And I think some years back, somebody said it was 2.5. He had 2.5 children. I asked who was the half child, and he says Aki and Popo. Okay, that's on a lighter note. But number of children are counting. You count the number of children, so you cannot have half. Okay, good. So, but when we come to weights are read, and it's read to the nearest whole number of the instrument that is what? Employed. So if the instrument, the scale is to 2 decimal places, your weight will be in 2 decimal places. But if the instrument is in 1 decimal place, then you're going to have what? Data to 1 decimal place, okay? So usually variables that are measured, quantitative variables that are measured, okay, are also another type of data because they always come with some points, okay? They are not like the counting quantitative what? Variables, okay? So we are establishing the fact that even at the quantitative, we can have 2 types, which are what? The discrete quantitative, the discrete are the counting ones, okay? 0, 1, 2, 3, 4, like number of children. And then the continuous quantitative variables, which come with the decimals, okay? Good. So let's go back to the flow chart to make it easy for us. So this is how it looks like on our flow chart. Just a minute. Yeah. So we're saying that the other quantitative, you have discrete, okay, quantitative variables like number of children, number of cars, Okay, age, age, you cannot have 62.5. Okay, age, it's either you are 62 or 63. You can't have 62 and half. Then we also have continuous quantitative variables like height and what? And weight. Okay, good. So that is for the quantitative. Now, when we come to the qualitative or categorical variables, we also have two types. When you look at the data we have here, okay, we have two main types. The first one is when you look at gender, we have male and female. You look at nationality, you have Ghanaian, Chinese, Nigerian. You can see that for gender, a male is not superior to female, neither is female superior to male. You understand? There is, I mean, it is unique in itself. They are two unique things. Good. The same way with nationality, Ghanaian is not better than Chinese, neither is Chinese better than Ghanaian. They are just unique classifications. Okay, good. So we have those ones where the data set are just unique classifications, where there is no order of, preference or something. Okay, good. But when we come to the next variable here, qualitative variable, which is rank. In rank, there are levels. Okay, there are levels. Okay, you move all the way from private. I think private is the very first level, to corporal, to sergeant. The military folks, you may probably correct me on that. Okay, I think we move from private to corporal to what? To sergeant. Okay, so there are order, and you can't go and refer to a sergeant as a private officer. Okay, so it's very important we take note of that. So under qualitative variables, we have ones where the data are ordered and others where data is what? Not ordered. Okay, good. Good. Now, how do we classify those two types of variables? So let's go to our flowchart and see where they fall. Good. Now, we call them, so we have qualitative and qualitative. You have the nominal variable like color, like gender, like nationality. Okay. You cannot say that color white is better than color red, even though it's your favorite color. You can't say color red is nicer than color green. But when it comes to ranks, okay, we have clear-cut ranks from assistant lecturer to senior lecturer, okay, it keeps going on and on and on. Okay, so we have ranks in academia, ranks in several places. And you need to meet some criteria or some number of years before you fall into the next rank. Okay, so at this point, I'll pause and then take your questions. Okay, Dr. Engineer says, so don't forget our very own Jata cement. Okay, that's a nice conclusion. Anyway, so let me take some questions. Let's have some questions if anybody has a question. So you lift your hand if there is a question or a contribution. Like I always say, it's not always about questions. So if you have contributions, you can bring it up. Okay. If not, we'll move on and we'll do some more. Some little calculation where we are going now. We're going to do some more calculations there. Okay. So we've essentially seen the type of variables, and we know that the response to the variables give us the data. So if variables are qualitative and quantitative in nature, then it means that our data are also what? Quantitative and qualitative what? In nature, okay? So you take that into consideration. Now, in the next aspect, we'll be looking much more into, let's say, quantitative data, okay? A lot of the things we're going to look at in class will dwell on quantitative data. Now, before we even proceed, we need to understand how to present data. We said data collection, data organization to data presentation. Now, so we need to understand data presentation. And as for that, everybody will have some idea how to plot pie chart, bar charts, histograms, frequency polygons, and so on and so forth. Okay. So what I'm going to do with you in class is to teach you how to set up the tabular presentation or tabular representation, okay, for any given data. And then we also need to know the format of the data and how we can represent it in the tabular form. Okay, then after that, we take one or two of these charts and I'll give you an assignment on data presentation. Very good. Now, we have data sets. When we're giving data, individual data like this, so in the simplest form, we have observations 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is data from 12 persons or from 12 experiments, okay? So this is raw data from 12 experiments. Good. And when the data is written in this format, we say it is what? It is in an ungrouped what? Format, okay? And as long as it remains in the grouped format,